Hello, welcome back. And today we will be looking at our last part of section 2.1. We'll be looking at something called domain and range today. Probably maybe something you've heard of before in your Algebra 1 class, but definitely something we're going to do more with this year than you probably have done in the past. So the domain, if you don't remember or if you've never heard of this term, it's the set of all your x values or all your inputs when you're looking at a relation or a function. Your range is the set of all your y values or your outputs when you're looking at a relation or function. A couple things we'll talk about more as we get further along into our examples, but might be helpful to even put here. Your domain, when you're looking at a graph, you're focusing on basically your left and right of your graph, how far it goes left, how far it goes right. When you're talking about your range graphically, you're talking about basically how far up or down your graph goes. So might be helpful when we get to the backside when we're focused on graphs to kind of have that kind of idea already implanted in your brain. But let's look at our first concept. So the first concept, we're going to look at how to write domain and range from map-ins, tables, or sets of points. When you do these, basically, you're just going to list all your x values and you're going to list all your y values. When you list these numbers, though, you're going to use these squiggly brackets around your number. I think the proper name for these, they're called French brackets, but I just call them squiggly brackets. They got a little squiggle. If you look on your keyboard, they're like slightly above and to the left of your enter key. You'll see you got to press shift to type these if you ever need to type them for some reason. But let's look at our first example. If you don't remember from a map, remember our left side are all our x values or inputs. Our right oval is all our y values or outputs. So when you write your domain, you put a squiggly bracket, and then you just list all your x values in this set. And I personally don't care what order you put them in. If you are looking at like a multiple choice test, they're probably going to order them from smallest to biggest, but usually I just list them in the order they're given to me. So I have a 7, I have an 8, I have a 1, and I have a 4. And then I put another squiggly bracket to close that set. But like I said, if you want to reorder them, if you wanted to do like 1, 4, 7, 8, because it makes you feel better, like you're more organized, that's not a bad thing. Like personally, I've just never been a big deal because technically it doesn't matter what order you have them in your set. It's still the same domain. Range, very similar idea, except we're going to be looking at our second oval here, because remember, those are our y values, and we just list them as they're given. So we have a -4, we have a 5, we have a 9, and we put another squiggly bracket. And that's our range. Those are all our outputs or all our y values. So not too bad when you have a map. And one thing just to kind of keep in mind, it didn't happen in this example, but you never want to repeat yourself when you do your domain and range. So if you have like a number that comes up twice, just put it one time. You never should repeat yourself when you're writing these. Let's look at our domain in the second example. So you could write the coordinates of your points, but really what we want to do for our domain is we just want to see what x values we have. So basically, how far left or right did I go to plot any of my points? So if you look like this first point, like it went over 1, like the coordinates of that point would be 1, 2. If you look, we have a lot of points that are over 2, and then we have a 1 point that's over 4. So those would be my x values. Like I said, you could write your coordinates if you did. You'd have 1, 2, you'd have like 2, 1, 2, 3, 2, 5, and then 4, 2. Like if you wrote, like those would be the coordinates of all these points. But the x values you see are just 1, 2, and 4. So we can just list those. And like I said, I know there's multiple points with an x value of 2. You just put it one time in your domain. Now let's look at our range. So basically, how far up do my points go? Well, so we're kind of switching gears. So if you look like this, we have this point goes up 1. This point here would go up 2. We have a point that went up 3. And then we had a point that went up 5. So I would just list those. Those are my y values. 1, 2, 3, 5, squiggly bracket. And like I said, you could write the coordinates of your points. Like if you look, like these were my x values. And then these were my y values. So like if it helps, you can always write your coordinates, but sometimes you should just be able to look at the graph. You probably don't need to do that, but if it's helpful, by all means, please write the coordinates. So maybe the trickiest example so far. But let's look at example 3 where they give us a set of points. So remember, all domain is, it's just the set or the list of all your x values. So I mean, our x values, we got a 7, a -5, an 8, a -9. So I'm just going to list those in the order they gave them to me. But like I said, you're welcome to order them from smallest to biggest if it makes you feel better. Like I said, if it's a multiple choice question, they're probably going to order them like that for you. So just be careful if you're like checking your answer for something like that. And then our range, remember, is the list of our y values. So we would just have -5, -2, -9, and 0. So I'm just going to write them with commas between them. And that's my range. So this is our first idea. You'll see basically if you have sets of points, you're just going to basically list your x values, list your y values, you're good to go. All right, concept 2 is where it's probably going to get a little bit trickier. This will probably take a little bit to click for a lot of you, but like I said, just pay attention to what I'm saying and try your best with these. So one thing, there's some symbols we're going to be using. You use square brackets if your number is included. Kind of like when we did like open versus closed circles with inequalities, it's kind of the same idea. If you have a closed circle as one of your endpoints of your function, you're going to use a square bracket. If something is not included, like say you have an open circle, you're going to use a round parentheses. Another thing to keep in mind, if your graph goes forever in a direction, like it goes up and up and up forever, or to the right forever, or to the left forever, or down forever, you're going to use either a positive infinity symbol or a negative infinity symbol to represent that. And that's just kind of like a sideways 8 if you've never seen the infinity symbol. And then the last thing that can happen is if your graph includes every number, like it goes left and right forever, or it goes up and down forever, basically every number is part of your domain or range. We have a special symbol we call it all real numbers. So to write this symbol, you kind of draw, sorry about that. You draw like 2 vertical parallel lines, kind of like this. And then from that first line you drew, you kind of draw a capital R. So this symbol means all real numbers. Basically, everything's included with your graph, and that's something that can happen in a lot of different types of functions we'll look at this year. But let's look at some examples. Like I said, I think this is something we're going to have to spend a bit of time on before it gets super comfortable. But this first graph, when we focus on domain, you basically kind of want to look at how far does your graph go left or right. So a lot of times it's helpful if you have a pencil to kind of draw a light kind of dashed line just so you can erase it. But if you look, I kind of like draw a dotted line from the left end, and I draw a dotted line going through the right end. So if I look, my domain basically goes from -9 to 11. And then you want to ask yourself, are my ends included? If you look, both ends of this graph are closed circles. So if you remember from above, we're going to use those square brackets. So my domain is square brackets. It's from -9 to 11. It's everything between them. That's what these brackets mean. Like that's saying everything from -9 to 11 is part of my domain. Similar idea for our range. Our range, we want to figure out how far our graph goes up and down. So you start on the bottom. So the furthest this graph goes down is there. The highest this graph goes is up here. So if you look at our y values, it goes from -2 to 9. And if you look, we still have closed circles. So it would be from -2. And then the highest it goes is 9. One thing I should mention, when you do your domain, you always want to go like put your how far it goes left and then how far it goes right. For your range, you always want to put like how far it goes down and then how far it goes up. You always want to go small to big when you list your domain or range. Let's look at an example 2. So like I said, if you're looking at your domain, you're looking at how far left, how far right it goes. So if you look, it's from -8 to 4. But if you look, the -8 is included, but see how that 4, that open circle, since that's not included, we're going to put a 4, but we're going to put a round parentheses. That means that end is not part of our function. It's an open circle, so it's not included. And then let's look at our range. So how far down does this graph goes? So the lowest it goes is -5. The highest it goes is 7. So that -5 is included because there's a closed circle on this end. But this open circle at 7 is not included because like I said, it's an open circle. So that's going to be how, like, if you, when you eventually get to your adults math, that's what the first section is going to be, like these two examples. But one thing you can see with graphs, for example, is sometimes they go on forever. Sometimes, like, if your graph has a beginning and an end, it's like this. But sometimes if your graph goes, like, if you see this graph, it just goes down straight forever. So it's going to go forever in that direction. So for domain, remember, you're thinking about how far your graph goes left or right. If you see this graph's going to go to the left forever, it's going to go to the right forever. So basically, it's going to include everything. It's going to go both directions forever. So that's where we could use our special symbol. That would be all real numbers. Our range, on the other hand, it goes down forever. So technically that's -infinity. Like, we don't have like a number because it's just going to keep going down further, right? If you say it goes down to -100, nope, it's going to keep going past that. But the highest our graph goes is -3. So basically it's from -infinity to -3. So you always want to start at the bottom. So it would be -infinity. And you always use a round parentheses with infinities because technically you can't include infinity because it's not like a real number. You can hold like 5 or 10, for example. If you have infinity dollars, what does that look like? But if you have $10, we can hold that, right? It's included. And then this graph goes up to -3, which is included. Like, there's, like, if it doesn't put an open circle, just assume it's like a closed circle. So that would be a square bracket. So we're going to practice some more problems of these together, but I just wanted to kind of introduce this in an Edpuzzle. I'm sure it's a little fuzzy. I hope it's not too bad though. So please ask questions if you're going through and you're like lost, but this is something we'll work on a lot in this class. So this is just kind of our first look at it. So I don't expect it to be perfect the first run through.